The Earth is home to 8.7 million species of life. Over billions of years of evolution, life has discovered ways of inhabiting every possible niche, including Earth's most extreme environments. And yet, for all of the exotic and colourful displays of life on this planet, its most striking feature is invisible. Beyond life's diverse and complex outward behaviours, scientists now agree that not only we humans, but millions of other species are also the subject of a felt inner dimension, a conscious mind. Of all of life's remarkable displays, it is this illumination of the universe through consciousness which makes life so extraordinary. While consciousness is unmistakably life's most remarkable feature, it is also its most mysterious. Despite all of our scientific advancements, we remain completely in the dark about how we or any other life came to possess consciousness. How could purely physical processes, such as those of the brain and nervous system, somehow create a subjective inner dimension? The very fact that reality supports subjective experience is an extraordinary mystery, comparable perhaps only to the mystery of existence itself. And yet consciousness is far more than a tricky philosophical problem. It is through consciousness that all meaning, value, and significance enter the universe. In conscious life, the universe creates a means through which it has become aware of itself. As the cosmologist Carl Sagan famously put it, we are a way for the cosmos to know itself. Viewed in this way, the emergence of conscious life is a moment of great cosmic significance, transforming the universe into a process capable of reflecting on its own nature and development. But is this simply an arbitrary event in an absurd and indifferent universe, or is it a clue to the deeper character of reality itself? An ancient and divisive question is whether conscious life developed through purely random events, or whether it was in some sense destined to happen. The controversy of considering this possibility stems from its teleological aspect, that the universe has a kind of purpose or goal. While teleological views were central to much ancient and pre-scientific thought, the rise of deterministic science and later Darwinian theory saw teleological explanations appear increasingly obsolete. Without any inherent purpose or overarching goal, the life of Earth could now plausibly be seen as having slowly evolved over billions of years, driven by nothing but blind and iterative natural selection. Together with the predictive power of determinism, it now seemed that a complete physical science requires no indwelling purpose, only a rigorous deterministic account of causes and effects. To argue that nature was predisposed to create conscious life is therefore to court controversy. At least on the surface, it appears to lend support to naive and pre-scientific views of the natural world. It also challenges the completeness of current Darwinian thinking, as well as the prevailing materialist view of the universe. Who then, aside from the religiously motivated, would dare defend such a heretical claim? It may be surprising to learn that several prominent philosophers and scientists argue that life and mind are no accident of evolution, and that the universe may indeed contain a type of natural teleology, a cosmic imperative towards the development of life and mind. It is this fascinating yet controversial possibility that we will explore today. Part 1. The Life-Friendly Universe. A surprising discovery of the last century is that the constants which shape the development of the universe appear finely tuned to permit the evolution of complex life. Change any one of a number of extremely subtle constants, and the universe becomes utterly inhospitable to any form of life or complexity whatsoever. The most famous example of this apparent fine-tuning is gravity. The force of gravity is approximately 1,000 times weaker than the other forces affecting the behaviour of atoms. It is now known that if gravity was only slightly stronger, stars would have developed from less material, and as a result would have been smaller with significantly shorter lifespans. From living around 10 billion years, typical stars would have lived only for around 10,000, which is of course a much shorter time than the billions of years required for biological evolution to take place. The consequences for life are also catastrophic if gravity had been just fractionally weaker. Stars would have burnt at cooler temperatures and so would never have gone supernova. The result would be that the heavy elements required for life would never have come into existence. Taken on its own, gravity is a conspicuous example of fine-tuning, and yet there are believed to be upwards of 20 such cases, extremely subtle constants, any change to which, and all hope for even the most imaginative notions of life, are crushed. If all of the discovered cases of fine-tuning are taken together, the probability of a life-friendly universe occurring through chance is trillions to 1. As the cosmologist Michael Turner has put it, quote, "The precision is as if one could throw a dart across the entire universe and hit a bullseye 1 millimeter in diameter on the other side." So what does this apparent fine-tuning mean? It is widely considered that there are just two possible answers: that either the universe was intelligently designed by a powerful creator, or that the universe is in fact just one among trillions of others, containing the full gamut of possible laws and constants, occupying a transcendent realm known as the multiverse. To those who lack faith, the religious explanation is unsatisfying, and yet the multiverse theory also has staunch critics within the scientific community. As the physicist Paul Davies has remarked, quote, "Invoking an infinity of unseen universes to explain the unusual features of the one we do see is just as ad hoc as invoking an unseen creator. The multiverse theory may be dressed up in scientific language, but in essence it requires the same leap of faith." End quote. What naturalistic process could possibly create a universe-generating mechanism that churns out trillions upon trillions of universes while simultaneously sustaining their differing laws and constants? How could such a complex mechanism come into existence, and based on what laws, and from where? Worse still, our questions about the multiverse may never be answered, because its transcendent realm lies forever beyond the bounds of our space and time. The multiverse is a fascinating metaphysical speculation about the larger cosmic ensemble. But, as Davies argues, a more measured response to fine-tuning is not to assume the existence of trillions of unseen universes, but to first exhaust possible explanations of the universe we do see from within. And given its mysteriously life-friendly conditions, Davies argues that we should take very seriously the possibility that life and consciousness are important features of it. Part 2. A universe of value. This was a view explored by the philosopher Philip Goff. Goff suggests that the universe may appear to be finely tuned precisely because it is. For Goff, what is conspicuous about fine-tuning is not that it permitted the existence of humanity, or even life in general, but that the constants are precisely those as to permit the existence of a, quote, universe of great value, and with it the necessary existence of conscious life. For Goff, the possibility that value is the causative force of reality is more plausible than it may at first appear. He points out that physical science reveals neither what things are in themselves or the underlying causes of physical events. In fact, all we perceive of the natural world are its regularities. It is therefore reasonable to consider that it is a responsiveness to value that animates the causal structure of reality. That, quote, the universe, through responding to value, fine-tuned itself. Another thinker who argues that the universe was predisposed to the creation of conscious life is the philosopher Thomas Nagel. Like Goff, an important element of Nagel's thinking is that he is a realist about consciousness. Both Nagel and Goff argue that consciousness is a real and undeniable feature of reality that science must eventually expand to include. We focused on this type of view in the previous episode in our exploration of panpsychism. And yet, while this has become a respectable, albeit minority position, Nagel also goes further, considering that conscious life may play an essential role in the universe, that it was required to exist. Nagel points out that neo-Darwinian evolution, as a purely materialist theory, offers no explanation of how consciousness emerged in living organisms or the function that it serves. And if materialism is insufficient to explain life's most striking feature, then a strictly materialist view of evolution is likely to be incomplete in other important respects. One area that Nagel considers is the origin of life. Several prominent scientists have pointed out that as a product of random molecular collisions, even the most primitive self-replicating cell is such a staggeringly complex system that it may be implausible to occur by chance in the entire projected lifespan of the universe. The fact that life emerged on Earth approximately as soon as the conditions for life existed therefore poses a serious problem to a purely random account of life's origin. According to Nagel, something other than random chance is needed to explain life's emergence from a dead environment. Something by definition non-random, something teleological. Problems facing Darwinian theory, Nagel points out, are often minimized because there doesn't appear to be any other natural explanation on the table. To criticize any aspect of Darwinian theory is often viewed as turning one's back on science and of offering support to supernatural alternatives. Nagel argues, however, that there is another option on the table, what he calls an alternative to a miracle, that evolution is true, but that it is not an entirely random mechanistic process, that the universe is predisposed to the creation of complex conscious life. But what is it about conscious life that is required by the universe? Similar to Goff, Nagel believes that the answer lies in a deeper understanding of value. Nagel defends a position he calls value realism, that value is not simply an illusory perception of animal appetites and aversions, but actually points to something true in a deeper sense. We humans, in our evolved and complex societies, have created elaborate and often conflicting structures around our perceptions of value. Yet Nagel argues that our raw apprehension of value within consciousness, most clearly apparent in the value of pleasure and the disvalue of agony and suffering, are not mere social or biological constructs, but are grounded in deeper truths about the real existence of value. For Nagel, these truths are equivalent to the Platonic truths of mathematics and geometry, that just like 2 + 2 = 4 would be true even if the universe didn't exist, there are truths concerning value which precede any physical existence. According to Nagel, if we accept value realism, we must also confront its larger cosmic implications. that existence entails value, and that life and conscious beings may therefore be required as its realizers. The philosopher John Leslie also defends a similar view. Leslie's focus goes beyond both evolution and cosmic fine-tuning to the ancient question of why anything exists at all. Leslie argues that no physical theory can ever explain the origin of the universe, because any physical cause must always be preceded by another physical cause. To avoid an infinite regression, Leslie argues that we must go deeper than physical mechanisms and consider that something altogether different, something more like value, is the realizing force of reality. Like Goff, Leslie believes that there must be some ultimate metaphysical sense in which it is good that the universe exists. And since it is only through consciousness that value or goodness enter the universe, conscious beings may therefore be necessary features. Part 3. Future Attractor. As compelling as teleological views might seem, they face a serious problem. If the universe required conscious beings, how did it exist in the billions of years before life arrived on the scene? To the best of our knowledge, there were no conscious beings at the beginning of the universe. Significant time needed to elapse for at least one generation of stars to go supernova before the heavy elements required for life could exist. One reason that teleological views are so controversial is that they appear to suggest that the universe deliberated about its future states and then somehow chose between them. Such an activity would appear to invoke the existence of a godlike mind, together with all of the inherent problems of explaining it. It would seem that through teleological thinking, we find ourselves back in theistic territory, attempting to explain the necessary existence of a powerful creator. There is, however, an alternative way of thinking about teleology, that rather than proceeding exclusively from the past, causes might also arrive from the future. Until recently, physics offered no possible mechanism through which causes could come from the future. That was until the development of quantum theory. In the quantum world, entities have been shown to exist in either a superposition of multiple states simultaneously or as a distinct actuality. It is only upon measurement that quantum entities assume the common sense behavior of classical objects. While this aspect of quantum theory is already strange enough, it turns out that the measurement of a quantum system not only determines the state of the system in that moment, but also resolves its entire history. In other words, in our choosing to measure it, we can decide how a system existed in the past. In quantum theory, this is known as the post-selection effect, and it introduces a surprising retrocausal feature of physical reality. Several thinkers have pointed out that this retrocausality opens the possibility of an entirely new way of thinking about the origins of the universe, that its initial state may be intimately related to its future states, and that past and future exist interdependently. The decorated theoretical physicist John Wheeler was both the first to recognize this quantum post-selection effect, as well as to explore its far-reaching implications. According to Wheeler, we have no reason to doubt that measurements we make at the present time stretch all the way back to the beginning of the universe, and thereby establish a consistent history of the present choice to observe. In Wheeler's thinking, we are not merely observers of the quantum world, we are participators in the origin of the universe itself. Wheeler considered that this could well be the reason that the universe appears so finely tuned for life, that only a universe capable of producing observer participators could establish what he called a self-excited circuit that brings the universe into existence. Wheeler summarized his view as follows, quote, "The participator gives the world the power to come into being through the very act of giving meaning to that world. In brief, no consciousness, no communicating community to establish meaning, then no world. On this view, the universe is to be compared to a circuit self-excited in this sense, that the universe gives birth to consciousness and consciousness gives meaning to the universe." End quote.
We have no right to say that the past exists independent of the act of observation. In this sense, we have become participators in the construction of the universe.
While it was seriously considered by several of the founding contributors to quantum theory, attributing any significance of consciousness in quantum measurement is now a controversial position in mainstream physics. In spite of this, several contemporary physicists argue that the possibility cannot be ruled out. One such physicist is the father of inflation theory, Andre Linde, who writes, "Avoiding the concept of consciousness in quantum cosmology may lead to an artificial narrowing of our outlook." End quote.
Consciousness enters into quantum physics at the point of observation, where the rules of the quantum game change as a result of that observation or measurement. Many physicists want to get rid of that, but I've always felt that this is a missed opportunity. If we're going to actually incorporate consciousness into our description of physics, it seems to me it's at the quantum level we should attempt to do that.
Part 4. The Cosmic Imperative. One way of framing the question of purpose in the universe is to consider what the universe is maximizing. Looking out on the universe from our current vantage point, it is by no means clear that the universe is maximizing conscious life. What is apparent is that far greater complexity exists in the universe than at any previous time. Furthermore, this complexity appears to be accelerating. At first, only simple particles existed, then an expanding diversity of stars, a vast archipelago of galaxies, the birth of heavy elements, and then life, first simple, and then exploding in diversity, consciousness, then consciously driven evolution with the potential of reshaping planets, and perhaps eventually the entire universe. Setting aside any significance of life or consciousness, how is this explosion of complexity possible? The traditional conception of energy in the universe is that all order is slave to and ultimately the victim of entropy, the second law of thermodynamics, which holds that over time all systems will tend towards disorder. And yet we live in an ordered and intelligible cosmos, not a chaos. And here lies the famous problem of entropy, that the universe, at least for now, appears to be not losing, but gaining order. It is important to recognize that entropy is not the enemy of life. Indeed, life's essential functions are deeply dependent on entropy. And yet, as defined as the tendency towards disorder, entropy predicts that eventually all stars will die, all structure will decay, and finally, after trillions of years, there will be nothing but a cold, featureless void. There is no question that entropy accurately describes the behavior of thermodynamic systems. But can we rule out that another kind of force also drives the universe towards complexity, and that the incorporation of this natural principle will dramatically change our outlook on the future of the universe? This view was defended by the neuroscientist Christoph Koch, who also sees a close relationship between complexity and consciousness. For Koch, consciousness is not an arbitrary emergence out of a sufficient degree of complexity, but instead that consciousness is among nature's deep fundamentals, and that it develops into more complex forms as systems acquire higher and higher amounts of integrated information. According to Koch, this is no accident of evolution. The universe is driven to maximize consciousness. In his 2012 book, Consciousness: Confessions of a Romantic Reductionist, he writes, quote, "I do believe that the laws of the universe overwhelmingly favored the emergence of consciousness. The universe is a work in progress. Such a belief evokes jeremiads from many biologists and philosophers, but the evidence from cosmology, biology, and history is compelling." End quote. Let us then consider that a cosmic imperative compels the evolution of consciousness in the universe. Where will this evolution eventually lead? Philip Goff has suggested that the existing universe might be as good as it gets, that the universe is not all-powerful in its ability to realize value, and that this may be why it contains, in addition to any value, many states of suffering and pain. Speaking personally, it would seem to me that to regard the present time in history as the apex of value is arbitrary, especially given the vast projected future of the universe and the possibilities of advanced conscious beings which could eventually inhabit deep time. It would seem to me that the universe's capacity for value is enormously greater than is currently represented, and not because of constraints in the laws of physics, but because it has not yet unfolded in time. A more viable signal of value to which the universe is responsive would be a singularity, a time perhaps trillions of years in the future, in which life and mind have saturated the entire universe, producing a highly conditioned state and a realized value trillions of times greater than anything currently in existence. The physicist Paul Davies, who has defended a role for consciousness in quantum mechanics, has also elaborated on John Wheeler's concept of the universe as a self-excited circuit. Davies considers that it could well be the destiny of life to saturate the entire cosmos, resulting in a universe that eventually achieves closure by becoming what Davies described as completely self-known. Davies is not the first to suggest this possibility. In the early 20th century, the philosopher Pierre Teilhard de Chardin argued that over billions, perhaps trillions of years, the natural course of evolution will lead intelligent conscious life to spread throughout the universe, culminating in a singularity of complexity, consciousness, and intelligence that he called the Omega Point. Is it possible that an apex of intelligence and consciousness reaches back across time to the beginning of the universe and participates in the conditions of its own existence? This theme has also been explored in science fiction. In the author Isaac Asimov's The Last Question, a superintelligence finds itself alone at the end of the universe, but now finally with an answer to its most fundamental question, and as it speaks the answer, creates the cosmos. But is all of this just wishful thinking, no more than an anthropomorphic projection of human desire onto a vast and indifferent universe? I would disagree. The arguments we have explored were put forward by thinkers concerned primarily not with human significance, but with a deeper understanding of the nature of the universe in which we find ourselves. To appropriate all value, meaning, understanding, and purpose to humans alone seems itself to be the height of anthropomorphism. It seems entirely justified to consider that these most striking features of the world reveal something important about the basic character of the universe itself. A view of the universe in which consciousness plays an essential role has the potential of entirely reframing how we see ourselves. instead of viewing our lives as a finite and ultimately meaningless struggle for survival in an indifferent universe, we become participators in a larger evolutionary process in which we are aligned with all other conscious beings in existence. In such a view, we are a part of a gradual evolutionary process, billions, perhaps trillions of years in the making, through which the universe itself is slowly waking up.